Data structures and algorithms using C. We will continue with the session on infix to postfix. So we will discuss the code to convert an infix notation into postfix notation. In the last session, I have already introduced you to the methods or the functions related to the stack. Now we shall see how we are going to use this in programming to convert infix notation to postfix. Here I have got the main program. As you remember, we have created this stack here and a new data type stack S. S is the variable of the stack type. And here we have all the prototypes of all the functions. First four functions, as you have remember from the last session, are related to the stack. And only these two are for the conversion of infix to postfix. As you see here, there is a infix to postfix. I pass as parameter the infix expression. It converts that into postfix and returns the starting address of that postfix expression. And precedence gives us the precedence of each of the operators. And in the main program, it is very simple. I've got an array called infix and a pointer postfix. So I init stack here. That means I assign 0 to s dot top there, and then I get the infix expression. I use getS, cannot use scanf, so I use getS function, and then I input infix, that is infix notation with brackets, etc. Then I call this function infix to post, and I pass this infix expression here. Automatically it converts that infix expression to postfix and returns the starting address, and I display that using putS function, and this is the complete program, main program. Now let us go to the two of the functions, precedence and infix to post. So precedence function is very simple. I pass the operator as the parameter, and then if it is power, it returns 5. It returns just the values of precedence here, because as you know, power operator has highest precedence, then comes divided by and into, then comes plus and minus 3 and left parenthesis 2 and right parenthesis 1, and it returns. This function is very simple functions, just to return the precedence of the operators, which we are going to use in the conversion of infix to postfix. With that, we come to the function. So infix to postfix, the infix array is passed as the parameter and returns the character pointer, that means starting of the postfix, that is postfix. Here I have created character postfix 30. So postfix itself is going to be returned here, and then postfix contains the starting address of this expression. So we initialize I and j as 0, and as you see, as long as every character which comes from infix notation, j is not equal to null. So this as long as I have not reached the end of the infix expression. So what do? We have got four options, as you remember. First option is left parenthesis. So if this left parenthesis, push the that left parenthesis onto the stack. I'm just going through the algorithm, then we'll get into the function proper. Then if it is one of these, that is character or it is a number, so it is an operand, insert into the postfix. So these are the operands. Operands automatically always go into the postfix array. Now the whole problem comes here. If strc, we are using this function strchr, that means if ch is one among these, then we know that it is an operator. Then we have to push onto the stack unless. So we go through various conditions immediately. We have done it already in the past session. Now we will program that, and we come to the last option. Is if it is right parenthesis, naturally you pop out all those operators which are there on the stack till you come to the left parenthesis, and if you have reached the end of the expression, there will be some operators left on the stack. You pop them and insert them into the postfix expression. This is the complete or algorithm, I would say. So left parenthesis, operand, operator, and the right parenthesis. Only 4 options are there, and the major thing is about the operator, which we will deal immediately. So if it is an operator, one of these, what do I do? If the stack is empty, push the scanned operator onto the stack. Very simple. Otherwise, what you do? Otherwise, there may be operator on the stack, and you have got the incoming operator. What you do is you pop that operator from the stack, you find the precedence of each of these operators and compare the precedence of the operator from the stack with the incoming operator. If it is for example, if it is greater, the precedence of the operator from the stack is greater than the incoming, naturally that will go into the postfix expression. If it is equal, then the operator on the stack is inserted into the postfix expression and incoming operator goes onto the stack. And if the precedence of the incoming operator is greater than that on the stack, then you push that operator from the stack back and also push that incoming operator onto the stack. And if there are other operators on the stack whose precedence is greater than equal, then till you come to that greater than equal, you pop them and then insert them into the postfix operation, and that is what we do. Repeat until, so pop the operator, find the precedence of that and compare, and as I said, so you either insert it into the postfix expression or you push it back onto the stack. So until the stack is empty or the precedence of the popped operator becomes lower than that the scanned operator. So if the precedence of the operator on the stack is low, then you push it back and push the incoming operator onto the stack, or otherwise you push the scanned operator into the stack. So this is the algorithm to the moment we get an operator, this is what we have to do. Either it goes onto the stack or it goes onto the postfix operation according to this algorithm. So let us see, this is the program now. So you have got character operator from the stack, ch is the incoming operator, and then static here postfix array you have got here, and precedence of the incoming operator and precedence of the stack operator from the stack. So then we initialize I and j to 0, and here we have as while ch from the infix is not equal to null. So this is that is as long as I have not come to the end of the infix expression. What do I do? As I said, first if it is left parenthesis, push it onto the stack. If it is one of these operands, then what you do is you insert it into the postfix and add a blank. Always add a blank so that they're separated from each other. Then if it is operator, as you see operator, if ch is one among these, what do you do? As I said, if the stack is empty, push it onto the stack. Otherwise, do while stack is not empty or the precedence from the operator from the stack is greater than equal to precedence from the incoming operator. Then what you have to do is you go on inserting it into the postfix expression, and as I said, add one blank after that. So otherwise, what if the precedence of the operator from the stack is less than the precedence of the incoming operator? As I said, push it back, the operator from the stack, and push the incoming operator onto the stack, or otherwise you push the operator onto the stack. So this is completely the code for the operator, incoming operator, what you have to do with that. Now we come to the last here, if it is the right parenthesis. So if it is right parenthesis, what do you do? So you pop the operator till you come to the left operator, still the left parenthesis which is on the stack, and you insert each of these operators from the stack onto the postfix expression. So you go on doing it till as long as you have not reached the left parenthesis, or it is not the empty stack. Then what we have come to the end of the while loop. That means you have come to the end of the infix expression. What do? There may be some operators on the stack. You pop them. So again, as long as stack is now empty, you pop and then insert it into the postfix expression. So this way we have done that. We have gone through all the four options: left parenthesis, operand, operator, and the right parenthesis. And therefore we have come to the thing, and at the end what you do is you add a null character, because postfix you have went on inserting the operators and operands into the postfix. Now you have come to the end, therefore it is very essential that you insert null character at the postfix expression and return postfix. That means it returns the starting address of the postfix expression. This completes the whole function of converting an infix notation into the postfix notation. So here you have got some examples of this. As you see here, this is the expression. So it gives you the postfix AB plus CD minus divided by. Here you got one more infix notation, and it has converted that into postfix notation. And as you see here, you have again one more in terms of numbers here in this case, because now in the next session we are going to convert, we have to evaluate postfix expression, which is only of numbers, and then evaluate that. So for example, here I've got expression in numbers, and this program will work only for single digit numbers, not double digit. You have to make some changes to accommodate double digit numbers. So you've got 7 3s, etc. As you see, this is the postfix expression from this infix notation. So this is how we are going to convert infix notation into postfix notation, and in the next two sessions we are going to check the evaluation of postfix expression. Thank you.